Ethereum is widely considered one of the greatest technological breakthroughs of the 21st century, not simply because it introduced another digital currency but because it reinvented the very idea of what a blockchain could be. While Bitcoin proved that decentralized money was possible, Ethereum proved that decentralized applications, contracts, and digital economies could also exist on the same cryptographic foundation. At the core of this revolution was a young programmer, Vitalik Buterin, who believed that blockchain could become more than a store of value. It could be a programmable, global computer. Ethereum was built on this philosophy. Instead of sending only currency, users could send logic, conditions, and rules that the blockchain would automatically execute. This simple idea sparked the rise of smart contracts, decentralized finance DeFi NFTs, DAOs, and thousands of new industries built around code that cannot be shut down, censored, or altered by any government or corporation. Ethereum's origin story is essential to understanding its purpose. Vitalik, after studying Bitcoin's architecture, realized that Bitcoin was powerful but limited. It could transfer value but could not automatically perform tasks based on conditions. This limitation inspired him to propose Bitcoin script upgrades, but the Bitcoin community rejected major changes. So, in 2013, Vitalik wrote a white paper proposing a new blockchain with a fully programmable language capable of building any type of digital agreement. Developers around the world immediately saw the potential. The Ethereum Foundation was created, funding began, and by 2015 the network launched with one of the largest open-source communities in blockchain history. Unlike Bitcoin, which had a slow development culture, Ethereum encouraged experimentation. And its early years were marked by explosive creativity. Token standards like ERC20, NFT standards like ERC721, and decentralized organizations. One of the earliest historical events that shaped Ethereum's future was the DAO, a decentralized venture fund built entirely using smart contracts. It raised over $150 million in 2016, becoming the biggest crowdfunding event in history at the time. However, a flaw in the smart contract code allowed an attacker to drain millions. The Ethereum community was forced into a decision that would define its identity: keep the hacked chain or roll back the blockchain to restore funds. The decision led to a split: Ethereum ETH and Ethereum Classic, etc. ETH chose to rewrite the past to protect investors, etc. chose immutability. This episode proved two things. First, that smart contracts are powerful but risky. Second, that Ethereum governance is community-driven and adaptable. Despite controversy, Ethereum's main chain continued to grow, attracting partners, developers, and major enterprises. After the DAO crisis, Ethereum improved rapidly. The network became the heart of the initial coin offering (ICO) boom of 2017. Thousands of projects launched tokens on Ethereum using the ERC20 standard, raising billions in a few months. This period brought huge attention, massive investment, and a surge in Ethereum's market value, but also attracted scams, weak ideas, and regulatory challenges. Yet, even as the bubble burst, Ethereum did not collapse. Instead, it evolved. Developers shifted focus from fundraising tokens to real utility, building decentralized exchanges, lending protocols, prediction markets, and automated financial systems. These experiments laid the foundation for what would become DeFi, an industry now valued in the billions, providing users the ability to trade, lend, borrow, and earn without banks or middlemen. Another major turning point came when Ethereum's network started experiencing congestion due to increasing usage. Gas fees soared during peak demand, reaching hundreds of dollars for simple transactions. Critics claimed Ethereum was failing at scaling. Supporters argued that the high fees proved huge demand and justified the need for upgrades. In response, Ethereum developers introduced a roadmap known as Ethereum 2.0, aiming to transition from energy-intensive proof of work to an environmentally friendly proof-of-stake consensus. This transition was one of the most complex software upgrades ever attempted in crypto history. The idea was to increase security, speed, efficiency, and scalability while dramatically reducing energy consumption. Ethereum's community embarked on a multi-year engineering journey involving the beacon chain, shard chains, rollups, layer 2 networks, and research collaborations with global cryptographers. The identity of Ethereum expanded beyond a technology; it became an ecosystem, a movement, and a global open-source laboratory where anyone could build the future. Governments, corporations, universities, financial institutions, and even central banks started exploring Ethereum-based solutions. Its flexibility made it suitable for tokenizing assets, issuing stablecoins, creating decentralized governance models, and building cross-border payment systems. Today, nearly every major crypto project relies on Ethereum or its standards. Even competing blockchains try to maintain compatibility with Ethereum's architecture because its developer base and infrastructure are unmatched. Ethereum's technology is built around an extraordinary idea: a decentralized global computer capable of running applications exactly as programmed. At the center of this system is the Ethereum Virtual Machine, EVM, a computational environment where smart contracts execute. Every node on the network, whether running in a home, a data center, or a cloud service, maintains an identical state of this virtual machine. When a user interacts with a smart contract, the EVM processes the request, updates its state, and ensures that every node agrees on the result. This is what makes Ethereum trustless. No central authority controls the code. If a contract says, "Release funds when conditions are met," it will happen automatically, with no human intervention. This architecture enabled thousands of decentralized applications, DApps, to emerge, from decentralized exchanges like Uniswap to NFT marketplaces like OpenSea. To use the Ethereum network, users pay gas fees, which compensate validators for processing transactions and executing smart contract logic. Gas fees fluctuate based on network demand and contract complexity. At times of heavy usage, costs can spike dramatically, making Ethereum expensive for beginners. But this challenge pushed developers to innovate layer-2 scaling solutions such as optimistic rollups, ZK rollups, Arbitrum, Optimism, Polygon, and many others. These technologies process transactions off-chain and then submit the final results back to Ethereum, reducing congestion and lowering fees. Layer 2 ecosystems are now essential for Ethereum's long-term scalability roadmap and serve tens of millions of users worldwide. They allow Ethereum to handle far more transactions per second, bringing it closer to supporting global-scale financial and social applications. One of the most transformative upgrades in Ethereum history was the merge, completed in September 2022. This upgrade changed Ethereum from proof-of-work, similar to Bitcoin's mining, to proof-of-stake, where validators lock up ETH as collateral instead of burning electricity. The merge reduced Ethereum's energy usage by over 99% and made the network far more environmentally sustainable. It also introduced the foundation for future upgrades such as sharding, which will divide Ethereum's data processing into parallel chains to dramatically increase capacity. The merge also turned ETH into a semi-deflationary asset because transaction fees, base fees, are burned under the EIP 1559 mechanism. This means ETH supply can sometimes decrease, giving it properties similar to digital gold while still being the fuel of smart contracts. Ethereum's technological innovation isn't just about improving the blockchain, it's about transforming industries. In finance, Ethereum powers decentralized exchanges, lending protocols, and stablecoins like USDT, USDC, and DAI. Billions of dollars move across Ethereum every day without a bank. In digital art and entertainment, Ethereum created the NFT revolution, allowing creators to tokenize artwork, music, game assets, and collectibles. This gave artists ownership and royalties guaranteed by code. In governance, Ethereum enables DAOs, communities that collectively manage funds and make decisions without leaders. In enterprise environments, companies use Ethereum-based solutions for supply chain tracking, identity verification, energy markets, and tokenizing real-world assets like real estate and government bonds. The future of Ethereum includes some of the most ambitious upgrades in blockchain: danksharding for massive scalability, proposer-builder separation (PBS) for fair block production, Verkle trees for smaller node storage, and a fully roll-up-centric architecture. These upgrades aim to make Ethereum fast enough to support billions of users without compromising decentralization or security. Ethereum's long-term vision is to become the settlement layer of the global digital economy, a base layer for all high-value transactions, smart contracts, and decentralized financial systems. In other words, Ethereum aims to be the Internet of Value. Even with challenges, high fees, competition from faster chains, regulatory uncertainty, Ethereum remains the most trusted smart contract platform in the world. Its community of developers, researchers, and users is unmatched. Its upgrade roadmap is the most ambitious in cryptocurrency. Its influence spans finance, gaming, government tech, AI coordination, and beyond. Goodbye. Thanks for watching.